Hey fellow problem solvers, Colfax Math here. Today I'm going to go over the Hesi A2 math exam. The way you learn how to juggle is by practice. The way you learn how to do well on any standardized math exam is practice as well. What I'd highly recommend you do is have a notebook and pencil in front of you, watch a portion of the video, get to a problem, solve the problem with the video pause, solve the problem yourself, unpause the video, and then watch how I solve it. There's a lot of tips and tricks I'm going to go over. This is a no calculator exam with multiple choice answers, so there's a lot of secrets to doing well that you'll pick up watching me do the problems. If you're studying for the ASVAB, these are also good practice problems as well, as is no matter how many standardized math exams you do, they're always going to benefit you when you take the actual test. So with that said, let's go ahead and get started. In this video, we're going to go over 18 questions of math for the Hesi A2 test. We're going to go over decimals, addition, subtraction, multiplication, division. Then we're going to go over fractions, decimal fraction conversions, limiting decimals, and recurring decimals. Finally, fractions, addition, subtraction, multiplication, division. If you never really got a lot of these ideas, I'm going to go over them in here, and hopefully they're going to start making sense. These are the foundational skills you need to move forward. I'm going to make a playlist of a few different videos to do well on the Hesi exam, and this is going to be the first one. I'm going to try and get one out a week, and we'll see how that goes. All right, with that said, let's get started. If you need any more help or information, you could go to this website. You could get it at the App Store or on Google Play and get a lot more help there. All right, number one. So I'm adding these decimals together. We'll go ahead and pause the video, do the best you can on this, unpause the video, and then see how I do it. Okay, unpause the video and I'm going to go through this. So I see up here two things being added together. They have decimals. The way to do this is 23.658. I got to line these decimals up plus 0.658. So there's a problem with the decimals lined up. And then before I even get started, I'm going to glance down at my answers and look over here. Well, this is going to be less than 1, and this is about 24. So I'm expecting an answer in the 24 ballpark. If I don't know how to do any of this, I could still cross out that one and that one because they don't even make sense. Right? They're not even close to 24. And then if I had a guess, I'd be able to guess between two, increasing my chances of getting it right 100%. Right? If I guess just randomly out of those four, it's 1 and 4 getting it right. Now I'm going to guess, and it's 1 and 2 to get it right. So as I add these together, I could just start over here. I start on the right side. 8 plus 8 is 16. I carry the 1. I look up here to see if either one of these ends with a 6. This is the one that does end with a 6. So that's my answer. But I'm going to keep going just to show you how to add decimals. 5 and 5 and 1 is 11. Carry the 1. 6, 12, 13. Carry the 1. 3 and 1 is 4. 2. And then that decimal comes straight down. They get 24.316. All right, next problem. We'll roll up here. Subtracting decimals. So the rule here is going to be exactly the same. This is less than 1 minusing less than 1. So I could see it's going to be one of the first two answers there. I could cross out these because I can't have less than 1 minus less than 1 be more. So those don't even make sense. Subtracting decimals can be the same thing. 0.5698 minus 0.39 minus 0.39. My decimals line up. These are just placeholders. 8 minus nothing is 8. I could go over there. Both of these have 8, so I can't answer just yet. 9 minus something is 9. So 9, 8, they both have that. 6 minus 9, I can't actually do that because this is less than this. So what I have to do is I have to borrow 10 from here, making this a 4, making this a 16. So now I have 16 minus 9 is 7. 4 minus 3 is 1, and I get 0.1798. Correct answer, answer B right here. All right, next problem. Make sure you're doing these before me. Now we're multiplying decimals. So let's say we have something about 40 times something about 10 in the 400-ish range. All these numbers are in that range, so I can't really cross any out. However, I know that it's going to be the last digits multiplied together. So if I'm running out of time and I have to guess, 7 times 9 is 63. So I know the last number is going to end in a 3. So I could cross out I could cross out those two right there. Let's go back up a step and do this. Okay, so I'm going to write it out. This operation is a lot different than adding and subtracting. Adding and subtracting, I line that decimal up. Here I'm going to keep track of how far over it is and then move it over. So let me show you that. I have 43.87 times 7.9. So my final answer, I'm going to count out how many places over my decimal is. It is over 1, 2, 3. So out of my final answer, I'm going to move my decimal over 3 places. 9 times 7 is 63. Carry the 6. 9 times 8 is 72. Plus 6, 78. Carry the 7. 9 times 3, 27. 27 plus 7, 34. Carry the 3. 36 plus 3, 39. Got a lot there. Then I got a placeholder here. So nothing goes there. 7 times 7 is 49. Let me change colors here. 49, carry the 4. 56 plus 4. 56 plus 4 is 60. Carry the 6. 21 plus 6, 27. Carry the 2. 28 plus 2, 30. I could add these all together to get 3. 17, carry the 1, 5, 16, carry the 1, 4, and 3. And remember how I moved, I counted this 1, 2, 3. I start right here and I go 1, 2, 3, and I get 346.573. Answer B right here. Okay, moving right along to problem number 4. 6.72 divided by 1.2. This is going to be pretty similar. I'm going to do division and then keep track of these decimal places over 1, 2, 3. So I have 6.72 divided by 1.2. I forgot to check my answers to see if any of them are going to be able to be eliminated. I don't really see any. Okay, so this 1.2, this goes over 1. This goes over 1, and it goes up right here. Then I have 12 and the 67. That would be 5. 5 times 12 is 60. That would go here. 7 minus 0 is 7. Bring down the 2. 12 goes into 62 6 times. Correct answer is 5.6. Answer B. Question number 5. Find the quotient rounded to the hundredths place. So what that's saying is, it's really saying divide this by this. We're going to do it the same way. We're going to go over here, find our white pen. Let's say 8.1 is being divided by 0.238. I'm going to take that decimal place and I'm going to move it over 1, 2, 3. So I got to do that over here too. 1, 2, 3. Got to keep track of my zeros. And my decimal place is going to go up right there. Now before I do this, I'm going to see up here, see if there are any answers I could eliminate. It's not really looking like it. They're all pretty close. I could tell it I could probably eliminate that 34 because it looks like I'm going to have a decimal. So 238 goes into 810 3 times. So this is going to be a 3 here. 238 times that 3 is going to give me 24. Carry that 2, 9, 10, 11. Carry that 1, 714. So I got 714 here. Then I have to subtract 0 minus 4. I can't do that, so I got to borrow 10 from here. 10 minus 4 is 6. 0 minus 1, I can't do that, so I got to borrow from here, making this a 7 and this a 10. 10 minus 1 is 9. I have 96. Bring down the 0, and then that's going to give me 4. 238 times 4 is less than 960. I could also guess that because 5 is going to give me 1,000, right? 5 times 2 is going to be 1,000. And almost all of those are 34. So I'm trying that 4. So 238 times 4 gives me 32. Carry the 2, 12, 13, 14. Carry the 1. 8 plus 1, 9. Gives me 942. 942. I'm going to subtract down here. 0 minus 2 can't do that, so I have to borrow. 10 minus 2 is 8. 5 minus 4 is 1. Bring down a 0. Have that decimal place there. 238 does not go in a 180, so it's going to be 0. Once I have that up there, let me look up there and see if I have to keep going. I don't. There's only one answer. That's 34.0. So I don't have to keep going because I know it's going to be answer A right there. So the correct answer to that problem is that answer A. Okay, question number 6, moving on to fractions. If you're still here, good on you for working so hard. Hopefully you're doing these problems with me. What is the equivalent of 9/11ths? This is kind of a tricky one. I think probably through order of elimination is probably the best way to do this problem. So how could I get an 11 to 55? I would have to multiply it by a 5. If I do that on the top, I would have to do it. If I have to do it on the bottom, I'd have to do it on top as well. If I'm doing this, I'm actually multiplying by 5 over 5. That is the equivalent of 1. So it's not changing the value. I don't know if I gave you enough time to pause and do this problem, was my thought there. So this is the equivalent of 1. I multiply across the top to get 45, across the bottom to get 55, and actually it works out to be answer A. That was a good try because I could see it was going to be an integer, and I knew it was going to probably work out pretty easily. If I did, which fraction is equivalent to 9/11ths? Well, let's do this one too. 9/11ths. How do I get 11 to 44? I'd multiply it by a 4. That would give me 44. I'd have to multiply the top by a 4, and that would give me 36 over 44. Oh, this one works as well. So both of those are right. How do I go from 11 to 65? 11 to 65 is what? It's not going to be an even number. And then 11 to 40 is not going to be an even number. So there are actually 2 correct answers there, A and B. I'm not sure those are right on the test there. Yeah, the test only has A, but B is correct as well. Okay, problem number 7. Go ahead and pause the video. Try this problem out. Do the best you can. Then I'll go through it. What is the simplest form of 12 over 48? So I'm trying to reduce this fraction, 12 over 48. I'm looking for a ratio that's the same as that. I could do it a couple ways. I could glance down there and eliminate answers. Right, 12 out of 48, I mean, I could see that's a quarter, but if I can't see it, this is clearly less than a half. This is more than a half. This is more than a half. I could eliminate those. Then right here, I can see those 2 things are the same. Right, 2 over 8 and 1 over 4 is the same ratio, but it's the simplest form. This one's simpler, so that's a better answer. So the correct answer, or not a better answer, it's the right answer. The other way I could do it through the process of elimination and looking at it. Another way to do it is see what goes into both these numbers. Well, 2 will go into here to give you 6, into here 24. 6 goes into there once, into here 4 times. Or I could just cut it in half again and get 3 and 12. 3 goes into here once. 3 goes into here 4 times, leaving me with 1/4. A lot of ways to do these problems. Some of them are faster than others, and on a standardized test, that's important. Let's keep moving here. Write 13 and 3/15 is an improper fraction. So an improper fraction is a large number over the smaller number. The number above has to be greater than the number below. Well, this is 13 and change. So if I had to eliminate a couple of answers and take a guess, because I'm running out of time, say, I would eliminate any value that is less than 1. So that doesn't make sense, and that doesn't make sense. So it has to be one of these two here. 13 is pretty big, right? 13 is a lot. This is only a little bit more than 1, right? And this is close to 13. So I could just eliminate that answer and know the correct answer is answer B. So correct answer is B. If you kind of go through a process of elimination, these no calculator tests, they're kind of set up to work that way. But let me go ahead and do this as well, just so you learn this skill. So you're going to take the integer, the whole number, and multiply it by the denominator. So I'm going to take 13 times 15 and get 3 times 5, 15, carry the 1, 3, 4. Placeholder, 5, 1. Add them together to get 5, 9, 1. So 195. So first thing I do is I take the integer, multiply by 15, right there, and then I add that number to it. So I add that 3 to it to get 198 as my numerator, my top number, over 15. And I can see correct answer is answer B. Again, a lot more computation here than just going through and eliminating answers that don't make sense. This is an improper fraction. Convert it back to a mixed number. So a mixed number is an integer in the fractional portion. So what we have here, the way I do that, I think of that fraction standing up like this, and it falls over to the right. So as it falls over, oh, whoa, whoa, whoa. What happened there? Let's go back. We're all getting tired, including my board here and me. All right, that fraction falls over to the right, so it falls over this way to say how many times does 7 go into 22? It's going to go in there 3 times with some change left over. So I can eliminate that and that. Let's keep going to figure out which one it is. 7 times 3 is 21. 2 minus 1 is 1. We're not doing decimals, we're doing fractions. So this is going to be my numerator. This is my denominator, so I have 3 and 1/7, which is answer A right here. Again, remember to pause the video, do these problems, and then watch how I do them. I know I'm not giving you much time to pause. All right, express this right here as a fraction. So this is 0.42 of 1. 1 would be right here. So this is the same thing as 42 1/100ths. So that would look like, I take that portion to the right, and I'm placing it over 1, which is 100 without the decimal place. So I end up with 42 1/100ths. I look at my answers. There's only answer A. I could have done that one pretty quick just with the examination and eliminating the other options. But it's really just checking your knowledge of place value with that problem there. All right, maybe if we're about over halfway through, maybe stop right here. Pause the video, stand up, stretch your legs, and then we'll come back and do some more. All right, here we are, question number 11. Write 0.150 as a fraction like the previous problem, however, in simplest form. So this is less than 1, so I'm going to have that 150 over 1,000. And then now I got to reduce it. So, right, it's pretty small. This is much more than 1, so I could eliminate that answer. And this is greater than 1, so I could eliminate that answer. This is what they call a natural distractor, right? If you forgot to put that place value in there because you're in the tens, hundred, thousands place, you're up to 1,000, so you have to have 1,000 down here. But if you didn't catch that, you could have done that one. Now I got to reduce it down. Well, I could knock these zeros off. 10 will go in there that many times. Then I left with 15 over 100. 5 goes into 15 3 times. 5 goes into 100 20 times. So correct answer is answer C, 3/20. Which is the equivalent of 17 over 25. This one's a little hard. You got to be able to see, we're going to go to decimals, and decimals by definition are parts of 100. So I have 17 over 25. If I want parts over 100, I need to multiply this by something. This something has to be a factor of 1 so I don't change the value of it. And then it's going to equal something over 100. So how do I get 25 to 100? I multiply that by 4. I know I want to go to 100 because that's what decimals are. 25 times 4 gives me 100. This number has to be the same as this number, has to be equivalent of 1, so I don't change the value of that. Then if I multiply this by 4, I got to multiply this by 4. 4 times 17 is 40 plus 28, 68. Then I convert that to a decimal, 0.68. Answer D right there. Problem number 13. This is just kind of math knowledge, actually. So this one you kind of need to know. You could grind it all out. But this is 6.666. Dot, dot, dot means it's continuous on to infinity. I look at all these answers. And I know this is greater than a half. So it can't be that one, or that one. This is the only one that's greater than a half. So there's your correct answer, answer D. Right there. You could do 66666 over whatever that is, 100,000, and divide that out and see that it's going to be 2 over 3. Again, no calculator exam means there's got to be a trick to it. So I just look through there and see this is the only one with the fractional portion greater than a half. Has to be that one right there. Let's express this as a decimal. So what we got here is we have 160 over 99. I'm thinking, you know, what's going to divide out there? It's not looking too easy. Let's see if there's anything I can eliminate. 99 times 2 is about 200, so I'm expecting something between 1 and 2, so those all look pretty good. It seems like that's a little low. I might be able to cross that out, but I think I'm going to have to do some of this. So what I have is 160 over 99. I don't really see any numbers that go into any of that to sort it out. So I think we're going to have to do that trick of the fraction falling over and start dividing. Hopefully we won't have to go too far, only maybe 1 decimal place, or if it's these, 2 decimal places, but I think we're only going to have to go to 1 decimal place. So that thing falls over. I want to know how many times 99 goes into 160. It goes in there once. There's my decimal place. 99 goes here. This is 61, right? Borrow. 61, 99 does not go into 61. What am I doing? Oh, no, I'm sorry. I got it 610. That's wrong. I got to remember, I got to bring another 0 down here, right? So I got a 0, bring this 0 down here. How many times does 99 go into 610? I think it's going to be 6. Yeah, it's going to be 6 because 99 times 6, 54, carry the 5, 54, 59. But it's going in there 6 times. I don't have to go any further than that. The only one up there with a 1.6 is answer A. That's our correct answer there. Again, that bar over the top, not that you need to know what that is for this problem, but if you want to know what that means, it means these two numbers repeat. So 1.61 barred means 1.61, 61, 61, 61 onwards. All right, problem 15, fractions, mixed numbers. We got a lot going on here. Actually, before we even do this fraction problem, let me just do a quick recap of adding, subtracting, multiplying, dividing fractions. If I have 1/2 plus 1/3, let's go back to that white pen. The only way to add or subtract fractions is a common denominator. So I have to use that idea of multiplying by 1 so as not to affect the value. I'm looking for a number that both of these could be. The number they could be is a 6. So to make that 2 a 6, I have to multiply it by 3 over 3. To make that 3 a 6, I have to multiply it by 2 over 2. Again, I'm multiplying by 1, doesn't change that value. That is going to give me 3, 6, plus 2, 6. Now I have that common denominator. The bottom number is the same. Now I add across the top to get 5, and I keep that common denominator 5, 6. So that's how I add fractions. Subtracting fractions is the exact same thing. If I have 1/2 minus 1/3, I have to have a common denominator. So I'm going to have now 3, 6 minus 2, 6. I add or subtract across the top, and that's going to give me 1. Right, because the subtraction I subtract, keep that common denominator 6. So that's how I add or subtract. Surprisingly, multiplying and dividing is easier. If I have 1/2 times 1/3, I just multiply across the top, 1 times 1, multiply across the bottom, 1/6. Then if I divide, it's kind of a weird rule here. So to divide, I go 1/2 divided by 1/3. The way I divide fractions is I multiply them by the reciprocal. So I convert that division to a multiplication. Reciprocal means flip it over. I flip that over to get 3 over 1. Now I multiply to get 1 times 3, 2 times 1. Woo! To get 3 over 2. Or as an improper fraction, I reduce that to a mixed number of 1/2. So there's a quick fraction lesson. Key to remember, add, subtract, you have to have a common denominator. Multiply, you just go across the top, across the bottom. Division of fractions is you multiply by the reciprocal. So with all that said, let's go ahead and do this problem. If I get my eraser to work, doesn't really want to work very well. And then we'll go ahead and do this problem here. What is going on with my board? Been a long day for that board too, I guess. Okay, so the way I'm going to add this fraction together, actually you take my lesson right there and then pause the video, do this problem. First, I'm just going to look at these numbers, 1, 2, and 5. I'm going to add those together to get 8. So it's going to be 8 and change. So it's not that one. Now I have 3/7 plus 5/14 plus 1/2. I think I want all those bottom numbers to be the same. So I have that 3/7. I have that 5/14. And I have that 1/2. Well, one number that'll work, that all of them will go into is 14. So I'm going to multiply this by 2 to get it to a 14. So 2 over 2 is equivalent to 1. That's going to give me 6 over 14 here. This is already a 14. And then this one, how do I get to a 14? I'll multiply it by 7. Again, it's got to be a 1, so that's a 7 over 14. Now I have common denominators there. I'm going to add across the top. 6 plus 5, 11. 11 and 7, 18 over 14. I also have that 8 from my integers. So I have 8 and 18 over 14. The way I'm going to do this, 14 goes into 18 one time with 4 left over. So this is an improper fraction, is the same thing as 1 and 4/14. I got to add that and that 8 together to get 9 and 4/14. So I'm looking up there. I cross this out, but I don't see my answer there. And that's because I have not reduced this. So I got to reduce this. 2 goes into here twice, into here 7 times to give me 9 and 2/7. Correct answer, answer C right there. Pretty hard problem there. But we're coming to a close. We're getting there. All right, question 16, same thing. But now we're talking about subtraction. So again, pause the video, do this problem. Unpause the video, watch how I do it. So the way I'm going to do this is I'm going to take a look at my integers first. That 9 minus 2 is 7. Then I got to figure out 2/3 minus 5/6. 2/3 minus 5/6. Common denominator is going to be 6. I'll multiply this by a 2 over a 2. Give me 4/6 minus 5/6. That's going to give me negative 1/6. So that means I have 7 and negative 1/6, right? So 7 minus a 6 is going to be less than 7. So it can't be that, can't be that. And it's not going to be much less than 7. So it's got to be that. But that even makes sense, right? Because I got 7 minus 1/6. Well, that's going to give me 6 and 5/6, right? 5/6 plus 1/6 is 1. And that's where that 6 and 5/6 comes from. All right. Multiplication of fractions. These are mixed numbers. We're going to stick with the rules we talked about earlier for multiplying fractions. So what we're going to do right here is we're going to turn these into improper fractions. Remember a rule to do that? I do 3 times 3, 9, plus the numerator, 11. So I got 11/3 times 1 times 2, 2, plus 1, 3 over 2. I can just multiply across the top, multiply across the bottom, and then see what I have. I could also reduce before I do that, rather than have to reduce afterwards. 3 goes into 3 one time. 3 goes into 3 one time. There's nothing left to reduce, so I multiply across the top, across the bottom to get 11 over 2. These right here are all mixed numbers, this improper fraction. So I got to turn this into that same kind of setup. 2 goes into 11 5 times to give me 10 with 1 left over. So 5.5. Correct answer, answer C. All right, here we are coming up to the last problem. Question number 18, find the quotient. So what we're going to do here, these are all mixed numbers. I think we're going to turn these into improper fractions and then follow the rule. So pause the video and do that. Give you a little start on it. And then unpause the video and we'll go through it. So I'm going to take this, turn it into improper fraction. 10 times 3, 30, plus 2 is, whoops. Oh, there's a giveaway. 2 and 2 31s. Let's go back and do this. I always forget my pen. Okay. 10 times 3, 30, plus 2, 32 thirds, divided by, I don't want to skip this step because I could get mixed up here. 5 times 6, 30, plus 1, 31 6. Again, multiplication, division, I don't need common denominator, only for addition and subtraction. The way I divide here is I'm just going to turn that into multiplication, and I flip this term over. So 6 over 31. So I have 32 over 3 divided by that, which means multiplied by the reciprocal. Now I want to reduce or cancel if I can. 3 goes into here once. 3 goes into here twice. I think that's all I could reduce. Multiply across the top, 32 times